Okay, the unit's called factors and products, but I just call it polynomials because that's what it is. It's just about the polynomials. So just a quick review. Polynomials, they have constants and variables and exponents. And the exponents have to be whole numbers. Okay? The exponents have to be whole numbers. You can jot that down. So you won't have any negative exponents, you won't have any fraction exponents, it's always going to be a whole number. 0, 1, 2, 3, etc. And the coefficients can be any real number. So you can have any coefficient, but the powers have to be specifically 0, 1, 2, 3, etc. And typically it's always in terms of x. You see how this one has like some y in there? We typically don't do anything like that in Math 10. Alright, let's keep going. So if you take a look at this, I would call 36 negative, I would call that the coefficient. In fact, I wouldn't even put numerical, I would just say that's the coefficient. And then I would call the x squared y5 the variables. That's what I would call them. So you have coefficients and you have variables. Coefficient, the number, variables, the letters. Okay? Okay, so these are called terms. Often I'll be referring to terms. That 36x squared y to the 5 is a term. And a term is essentially based on its variables. So you would try to find other x squared y5s to match these up with, like terms. Now polynomials are made up of a whole bunch of terms. Polynomials are expressed as a sum or difference of terms. You add them up, you subtract them, whatever you want. Like, let's take a look at this one here. This is very common for Math 10. How many terms are there? Good, 3 terms, because they're separated by plus or minus. And those 3 terms are all unlike. There's an x squared, there's an x, and there's a constant. How about the one beside it? How many terms on this one? 2 terms. Good, because they're separated by plus and minus. You guys clear on what a term is? Do you see this one by himself, 6? Does 6 ever change, or is 6 always 6? 6 is always 6. We call that a constant, because it's not dependent upon a variable. Whereas, see, x could be any number. So x is a variable, not a constant. What if I took that variable and added 6? Well, that's an expression. In fact, they're all expressions, but there's an expression, x plus 6. They're all expressions separated by plus and minus. The terms separated by plus and minus. Okay, let's keep going. If you think to your English prefixes, mono meaning 1, bi meaning 2, and tri meaning 3, that you can see that these polynomials, poly meaning many, because you could have all different amounts of terms, have some special names for 1, 2, and 3, namely the monomial, the binomial, and the trinomial. And then after that, we just call them polynomials. So like 4 terms, that's polynomial. 5 terms, polynomial. Just like you have like pentagon, hexagon, octagon, those are all polygons. Poly meaning many. Well, these are all nomials. 1 nomial, 2 nomial, 3 nomial. This just sounds weird, so they call it mono, bi, and tri. Alright, let's go through this chart. In the first expression, how many variables are there? X, Y, and Z, there are 3. And how many terms? Very nice. There's only two because they're separated by the plus. The 4x is a term and the 3yz is a term. And because there's only two terms, we call it a binomial. Bi meaning two, like a bicycle, two wheels. Now the next one, how many variables has it got? A, B, and C. But there's three terms, so it's called a trinomial. Very nice, you guys. This is a bit of a review, is it? Feels like it, right? Next one only has one variable, and that variable is x. But it has three terms and is therefore called a trinomial. Now the next term, or the next expression, only has got one term and one variable. It's the square root of 2 multiplied by x. X could be anything. Just take a look at, you got to zoom in on that guy. Do you see how the square root like stops on it? So like the root is only on the 2, not the x. So that's square root 2 multiplied by regular x. With one term, we call that mono. Very nice. Monomial. Sorry about that. It took me a while. Now the last one, how many terms and how many variables? 4 terms, and x and y makes 2 variables. So because it's a 4-termer, I don't got a special name for it, so I'm just going to call it a polynomial. You could call it a four-nomial. Maybe you could call it a quadnomial or a tetranomial. I don't know. A rat. Now this one is going to be tested for sure. It's a multiple choice question. This one's called degree of the polynomial. Students always forget about the degree of the polynomial. You're just looking for the highest power. The highest power. Now most of the time it's pretty straightforward. Like this first one, the degree is just 5. And like I'll just write one for you up above. X cubed plus x squared plus x plus 1. That's a polynomial. What's the degree of this guy? 3. And this is a pretty standard way of writing it. Do you see how the powers are in like descending order? What's the power here? What's the power here? What's the power here? Even though it's not written, the power is 1. And then here the power is actually, very good, x to the 0. Yeah, very nice. Okay, so it's always written in that descending order. So it's pretty easy to identify the degree when it's written like this, and this is pretty standard for Math 10. Now on the multiple choice question that you'll probably get, it's going to have this like special case where you have to find like the sum of the exponents. And this is for a monomial. Like take a look at this next one. Negative 2/3 ab cubed c squared. If you added all those up, the degree would be 6. 1 plus 3 plus 2. It's the sum of all the powers. Okay, that's one multiple choice question. It probably is not going to affect your life. But I think just the takeaway is like this thing I put in the box. Like make sure you can just scan a polynomial and be like, okay, boom, that's a degree 3. Like a polynomial in one variable, that's what you're going to be getting like 99% of the time. You should be able to spot the degree like bang. The degree will like tell you like the characteristics of the polynomial. Okay, now the next one. This is degree 4, degree 4, degree 5, degree 0. I did each term separately. Before we get into it, why is the last one got degree 0? Yeah, any whole number, just a constant. The constant always has degree 0. So if you look at this, 2 plus 2, you guys okay with that one? 4 is by itself, and then the last one, why is it 5? A 1 and a 4, good. So like the whole degree of this polynomial is 5. It's literally just find the biggest degree for any one term, and that's the degree. So like this one is degree 3, this one's degree 4, this one's degree 2. So the highest one was 4, so the whole polynomial is just degree 4. You just got to scan the powers. Okay. And that's just a definition for degree. Okay, algae tiles. You're going to get shown algae tiles whether you like it or not. Some people hate these things, some people like them. We're going to use them to introduce these polynomials, but I'll show you a technique that's quick, that's based on these. So this should be a review. The units, I call these ones the units. I call these ones the bars, and these ones are obviously the squares. Now they're going to tell me that the shaded ones are positive and the unshaded are negative. That's just a convention that we're going to adopt for these notes. So you could use that legend to write expressions for these algae tile diagrams. This is a negative x squared plus 2 bars, so 2x plus a 1. Each shape represents a specific term. This helps for understanding in the sense of like terms. You can only put like terms together. So you can see, like, how many x's do I have? There's 2 bars, so 1 plus 1 is 2. These pictures help you understand like terms. And then when you get more complex things, you can abandon these algae tiles, but they help for understanding. Like, you have 2 shaded squares, so you have 1 plus 1 is 2. You have 2 of those objects, and each object is an x squared. This is a square. And you have 2 of them, hence the coefficient 2. Then you have a minus x and a plus x, a minus 3 and a plus 2. Collecting like terms, this will simplify to 2x squared minus 1. You can see these as like a 0 pair. If you have the exact same shape, one is shaded and one is not, they come together for a 0 pair. Like a minus x plus x is just 0. 0x, which is 0. Think of it as like you give someone $1, then you gain $1, you're back to where you started. And the last one, I cancel out these 0 pairs before I even start, and I have 3x plus 2. Okay, so 0 pairs, the other big idea here is like terms. I'll be saying like terms a lot in this unit. So today is just review for the most part, I believe. Alright, so we're going to be able to add and subtract right here. Highlight it. The photocopying is not great. You're going to be able to add and subtract polynomial expressions using algebra. And what that basically means is you put the like terms together. Unlike terms not together. Alright, so like for example A, or the first example, like number 1, step 1, recognize the like terms. What types of terms do you have? You got A's, you got B's, and you got C's. And it's just a sum total. Okay? It's just a sum total. And each coefficient, I'll put a star here, each term is either plus or minus. This is the only option for these guys. They are pretty basic creatures. They can only be plus or minus. They got 2 options. So like take a look at 6a. Is he plus or minus? 6a. He's plus. But the negative 9b, he's minus. So don't get them confused. And you can rewrite them. You can rewrite them. Like for the first one, I would put all the a's together. Now you don't have to do this when you're, getting better at it. But for this first one, for understanding, like put all the a's together. 6a plus 5a. Are there any others? No. And notice how I just take the sign right along for the ride. Let's do the b's next. Negative 9b plus 5b. Each term has a specific sign. And then the last is c. So negative 2c plus 7c. It doesn't matter the order that you add them in. Like, is 2 plus 1 the same as 1 plus 2? Yeah, so it doesn't matter to the order that you add them in. It just makes sure you take the appropriate sign. So how many a's you got? Yeah, 6 apples plus 5 apples is 11 apples. Negative 9 bananas plus 5 bananas is negative 4 bananas. And then negative 2 Charlies plus 7 Charlies is 5 Charlies. Okay, so you have to collect like terms according to the variables. A's go together, B's go together, C's go together. Now for the next one, which ones go together? I'll use a different strategy. Maybe I'll use a highlighter. I love to highlight. Squares go together. M's go together. And then lastly, the constants go together. Any questions about that? I think it's pretty clear. How many m squares you got? Negative 8 plus 3. Negative 8, and then you got to add 3. Negative 5. And for the yellow, just the m's. You have 6 m's, and then you got to take away 13 m's. So altogether you have negative 7. And then for the highlighted pink, a positive 9 and a positive 2, when those guys sum total together, they become positive 11. So it's all just a sum total. Positives and positives, or maybe they're positive and negatives, or maybe they're negatives and negatives. So you got to go back to those integer operations that you're so familiar with from junior high. Yeah, this should be some review from grade 9, collecting like terms. And the last one here, like just identify what you got. How many x squared y's are there? And then the xy squareds. Do you see how those are all mishmashed, but the way that I've symboled them, they go together like this? So for the underlying terms, they all have something in common. That's the coefficient, x squared y. And you can think of x squared y as an object, like an apple. So for the x squared y, I'll just think of that as an apple. There's 6 apples. Take away 5 apples, and then plus 2 more apples. 3 apples. But I called apple x squared y. So I have 3 of them. 3 of them. Now the xy squared, those guys are the oranges. I lost 3 oranges, then I gained 2 oranges. So I'm still down an orange. And then I lost another 8. So I'm down 9 oranges. I'm down 9 of them. So it's 3x squared y, take away 9xy squared. You have to think of the coefficient as like a weight. The weight. X squared y, how many of those do you have? You have 3 of them. Xy squareds, how many of those do you have? You have minus 9 of them. The variable is just an object, an algebraic object. Like this right here. Just think of that as an object. You have 3 objects. And this is a different object because it's got a different expression. You have negative 9 of that object. Hopefully that helps you with your algebra. Okay, so you guys can try this. You can expand and simplify. It just means you have to add. So actually just do the first one, please. Just do the first one. Just do the first one. All right, so for the first one, how many x squareds you got? Good. It's just like, it's just 3, a positive 3, and then you're going to be adding a positive 8, so altogether 11. Now the next one, how many x's you got? Negative 3. Good. Takes care of those. And the last one, positive 2, positive 9, and a negative 7. Good. Any questions before we amp up the difficulty? All right, here comes the difficulty. And I'm just going to put a note on this one because it's tough. Maybe I'll put it on the side here. Subtracting. I'll keep the word simple. Subtracting brackets. This is probably the #1 mistake that could happen and will happen to some of you. Happens every year. This is it. Like if you're riding a bike and you lean too much to the left or the right and that's the reason you fall, that's a pretty common mistake. When you're doing this type of algebra operations, subtracting brackets is the #1 error. If you want a surefire way to always make this work for yourself, you have to think about this negative, changing the sign of each one of those terms, because what's happening is you're subtracting all of that. You have to subtract that whole bracket. So you have to subtract the 7x cubed, you have to subtract the 2x, and you have to subtract the negative 5. And I find that if you whisper to yourself while you do this, it actually helps. So you got a minus 7x cubed minus 2x, and you got a minus negative 5. If you have to minus a negative, you're plussing. Continuing on, you have to minus negative 16x squared. So that becomes plus. Pardon me, cubed. Then you have to minus 2x. Then you have to minus negative 4. That becomes a plus. So I think whispering it in your head is a good strategy. Now I'll go through them term by term in order. So let's do the cubes. Positive 5, positive 16, that's positive 21, minus 13. Positive 21 minus 13, I got 8. Whoa, why am I doing that? Good thing I got an undo button. Starting over, 5x cubed and a 16x cubed, that makes 21. And then 21 minus 7, 14. Are you guys okay with the collecting the like terms of the cubes? We're good on that one? All right. What's the next one in order? The squares. Are there any squares? So we have 0x squares. Do you need to write that? No, you don't have to write 0x squared. But you're aware that it is there. It just has a coefficient of 0. Now what about the x's? Minus 13, minus 2, minus 2 again. That makes minus 17. And then last but not least, we have the constants. A 17 and a 5 and a 4. I got 26. How do you guys feel about that? Feels good? Now that you have that one under your belt, why don't you try the last one? Try the last two. Try the last two. Someone said they're done, so maybe they want to hurry up. So let's try these last two. Give you about 2 minutes. Give you about 2 minutes. All right, so some good questions just come up. He says, like, with this next one, if there's nothing written, is it assumed that there's a 1 there? So then you have 1x cubed y squared, and then you're adding, so that makes life a lot easier. You just keep the signs the way they are. 1, take away 8, negative 7 x cubes y squares. Now for the x square y square, you have positive 7 take away 6. That leaves just 1. Do you have to write the 1? Could you? Do you need to? So that 1 is optional. And then the last one, negative 3y plusing 2y. That leaves you negative y. Most people happy with that? Feeling good about the like terms? Now for the challenge. For x squared y squares, 6 take away 2. There's 4 of them. And for the xy's, you have negative 4 of them. And you subtract 2 more. So that makes negative 6 of them. And then last but not least, you have a positive 3 to subtract a negative 4. 3 plus 4, 7. Hopefully you were able to accomplish that one. No questions? Taking that as people are comfortable or shy, one or the other? All right. To multiply monomials. Use exponent laws. This is the same stuff now as what we just finished in the previous unit. So it's not like you can just forget about the stuff from last chapter. How to use the exponent laws. Coefficients go together. X's go together. And y's go together. 3 times 7 is 21. X times x squared is x cubed. And y times y is y squared. You just literally count them up. X times x squared. There's 3 of them. Y times y. There's 2 of them. And 3 times 7 is 21. How about this one? This would be 2 times 9 in the numerator and a 3 in the denominator. And those x's are in the numerator. 2 times 9 is 18. 18 divided by 3 is 6. So the answer is 6x squared. Did I have to go that way? What's 9 divided by 3? 3. And then 2 times 3 is 6. So it doesn't matter the order, just as long as you do it properly. 6x squared is what you're looking for there. 2/3 of 9 is 6. Now to divide them, it's the same deal. Same deal. 34 divided by 17 is 2 over 1. Here now you can think of it as like a subtraction. Is 2x cubed as a final answer? I mean, 34 divided by 17, that's 2. People are okay with that. 2 over 1, or just 2. Now, it's a counting game for the x's. There's 4 up top, 1 in the bottom. So altogether, you get 3 of them. This is more review from last chapter. Question? You should start going to the washroom at lunch. You ask every day. Yeah, so go. And the last one. A negative divided by a positive. Negative 4. 36 divided by 9 is 4. And then m cubed divided by m squared. That's m 3 take away 2. It's just negative 4m. You don't have to write the little 1 up there. So same rules apply for dividing. Got one more page to do, guys. The distributive property for monomial binomial. Monomial multiplied by binomial will look like this. A outside of b plus c. It's basically you have a term being multiplied by, here I'll start over. It's an expression multiplied by an expression with 2 terms. Okay, an expression with 1 term multiplied by an expression with 2 terms. This has to be multiplied into both, and you would get a times b plus a times c. They call that distribution. So you have 3x times 2x. Well, 3 times 2 is 6, and then x times x is x squared. And then 3x times 5 is negative 15x. You guys feel okay about the distributive property? For monomial by binomial. Now on the second example, the product is just on the other side, so you can just think of it coming in this way. 5x times 10x, or pardon me, 5x times 2x, 10x squared, and then 5x times negative 1, negative 5x. And one more for the distribution. So as the first term multiplies, you know you're going to have x times x is x squared. Now you just have to think of 8 times 3 divided by 2. That was quick. Some people get a little bit turned off by fractions, but you just need to think of it as the top number being a times and a bottom number being a divide. So 8 times 3 is 24. 24 divided by 2 is 12. So you have 12x squares. And then as it multiplies onto the next one, it's just doubling. A positive times a negative, so it ends up negative. So on all 3 of these, you had a positive times a positive, which comes out positive. And then for the second term, you have a positive times a negative, which comes out negative. So not only are you remembering your exponent laws, your times tables, you also have to be aware of the integer rules for multiplication. Positive times positives, negative times positives, and negatives times negatives. Now the last part of this page, dividing, is essentially the same thing. Like, I'll rewrite the first one. This is all that's happening. When you divide a monomial, you're essentially just multiplying by the reciprocal. So essentially what this means is you have to times both of them by the reciprocal. Or in other words, you just need to divide both of them. So 6x cubed divided by 2x and minus 2x divided by 2x. Okay? That whole numerator is being divided by 2x. Okay, you get 3x squared minus, I'll wait for you. Let's just keep it simple. Slow it down. Why do I have 3x squares? 6 divided by 2 is 3. And then x cubed x1 makes x2. Now for this last one, what do I put here? What happens when they're identical? Top and bottom. Cancel, and which leaves you with a... Yeah, leaves you with a 1. So it's 3x squared minus 1. Okay? So you can think of this like... Whoops, wrong button. Heard the word cancel. And when you cancel, it leaves you with 1. 1. And I'll just put up on the whiteboard. What's 5 divided by 5? 1. Since if I had 5 objects, and I grouped them into 5 groups, how much is in each group? 1. Now you can extend that idea to x divided by x. The only time this fails is if x is equal to, this is a fail. You cannot divide by 0. So it always works unless x is equal to 0. So you can put that here if you like. X can't be 0. So for the next one, you think I got to take that numerator and divide each of those terms by the denominator. So I got a 10a squared take away 2. Any questions about the second one? Any questions? It's pretty much the same stuff. Is a allowed to be 0? No, it cannot divide by 0. This is going to work as long as a is not 0. Now the last two, this is for sure these are like multiple choice questions. I would study these two. For the first one, it's two-dimensional, and they've given you capital A. Capital A stands for area. Area of a rectangle is equal to length times the width. Now, we're using x's for variables, and I got an x here for times. At some point in your life, you're going to have to ignore or stop using the times as an x. Okay, so you can just write this. Area equals LW. I can substitute in the area. I'll use a color to show you this. Sub it in right there. 25x squared minus 10x is equal to, now the length we can call 5x. So I can sub that in there. And I'm going to be multiplying by the width. So 5x times the width is equal to the area. If I want to solve for the width, w, I would have to do the opposite of times, See how it's length times width? You got to do the opposite of that. So divide out the 5x on both sides. And in that sense, you can solve for the width. It's just an application. All right, 25 x squares divided by 5x. Take away 10x divided by 5x. This equals w. Dividing each one of those separately, I got 5x minus 2 as w. 25 divided by 5 is 5. X squared divided by x is x1. 2 take away 1, 1. 10 divided by 5, 2. X divided by x, 1. You don't need to write the 1. And it stays negative, yep. Now for this third one, it's asking for volume of a rectangular prism. The volume of a rectangular prism is length times width times height. So we have 4m plus 2 multiplied by 2m multiplied by m. So you have 3 terms that you have to multiply. Does it matter the order that you multiply them? No. So what I can do is I can make one of those last 2 terms I can make simpler. Put these together. What do you get? 2m times m. 2m squared. And then now you can distribute these two. 2m squared times 4m, 8m cubed, and 2m squared times 2, 4m squared. And this is the expression for volume. So the polynomial worksheet is your homework. It's not too long.